So how's your metabolism going? Like 1 hour after lunch, it's the deepest coma for everyone, including me. So yeah, so hi everyone. Thank you for listening to my talk. Yeah, I'm going to talk about some best practices in integration testing. And the previous talk from Marcin was a really good warm-up. There is a bit of overlap between our topics, but I'm going to unfold on some points that he already mentioned. So a bit about me. My name is Balazs Zagyvai. I'm a software engineer working with Scala for the last 6 years. Currently, I'm working with Ziverge, which is a great place to be. So if you're looking for exciting client projects and professional growth, then please consider joining. So I have had a few small contributions to ZIO, and one of them was about a way to improve integration testing. But let's jump ahead so much. So this is what we are going to try to cover in the next 25 minutes. So first, some background in testing in general. Then we will discuss why is integration testing difficult. Then we were going to look at how Scala Test and ZIO Test supports us writing these tests. And I will try to rush up all these sections so that we have more time for the last section, which is about composable specs. Yeah, so this is the well-known testing pyramid. That's the classical taxonomy of the different kinds of testing or different levels of testing. On the right-hand side, you can see some hypothetical software system that is made up by a few services and some infrastructural components. So let's see what we do at each level of testing. So unit testing is the lowest level. Here we focus on one singular component of a service, and we try to verify that it works according to some specification. So we like them because they allow us to localize the errors very precisely in the software. And usually we write many of them because they are quick and cheap. And there's a range of libraries that gives us great support to write this kind of tests. The problem is that they are usually very tightly coupled to the implementation. So once you refactor your code, chances are that your unit test is going to break. So that's one problem. The other is that they don't give us any confidence whatsoever that our system is going to work. Because individual modules may work very well in isolation, but defects can still exist. So there might be some interface issues between components. So during integration testing, we try to verify that the components work together when they are put together in the system. And then they are able to communicate with external elements. So many developers regard integration testing as the sweet spot of testing because although the library's support is not as great as for unit testing, but they provide much higher confidence. So if your integration testing goes well, then chances are that you have a healthy system. And if they don't go well, then you still have some chance to debug your issues. So system level or end-to-end testing is when we put together all the components of the system and try to run them in an environment that is very similar to production. So the only good thing I think about system testing is the confidence that it gives you, and that's all. But virtually there is no library support to write these tests, and they tend to be extremely slow. And if you discover some problem at this level, and you need to debug this, then yeah, good luck with that. It might be a nightmare. So, so integration testing is very important, but it's much harder than unit testing. Why? Why? Because the real world is quite messy. So once we leave the realm of unit testing, we have to start interacting with real infrastructure components like databases, persistent queues, caches, whatsoever. Yeah, so in the real world, we sometimes have to, for example, check an environment variable before we can start a test. Or we have to consider which kind of platform we are running. Like some tests may run on JavaScript, some other on JVM. Also, the operating system can make a huge difference. Some stuff we can run on Linux or Mac, but not on Windows. Also, sometimes we just have to acknowledge that some of the platforms are flaky. Maybe there is some source of non-determinism, so we have to accommodate for that as well. Also, we may need test data. We may choose to load a higher volume of test data to uncover like concurrency issues and so on. And we need to do this, all this in a way that we don't leak resources like file descriptors, memory, threads, and so on. So we need to define, acquire, and release actions and run them at the right time. So let's see in the next section how Scala Test tries to support us in integration testing. So just quickly, this is a simple Scala test. Let's try to break it down a little bit. So down on the bottom, we can see just a simple test that tries to use a service to make a database query and make an assertion on it. In order to set up our dependency, we have declared two mutable variables and a before and an after action where we initialize these components. So first challenge, let's add the timeout to this test. And sorry, it's sort of important to mention that as you can see, I have a for comprehension at the bottom. So this is an asynchronous API that we are going to test. So that's why we extend the async flat spec. So back to the timeout. So we need to mix in a trait for this and define a time limit. Problem is that Scala Test cannot really interrupt our test. So all it can do is it will tell us at the end that it took more time than we wanted, but it cannot interrupt it. For the synchronous case, it's a little bit better. At least they can send a thread interrupt signal. Flakiness. So for flakiness, we need another trait. We need eventually. And we can define a global timeout with this patience config. And we can wrap our test invocation with eventually, where we can have a specific timeout for this test. Important to mention that we have to get rid of the previous trait or mix-in because the timeouts are going to conflict. Yeah, and the other problem is that the way how eventually we'll try to retry to run our test, it's hard-coded. So you have this timeout and the interval, and that's it. You cannot have a specific schedule. Yeah, let's see what we can do when we have to check the, I don't know, environment variables or the platform that we are running on. So there is a basic mechanism to cancel our test. But Scala Test doesn't give you any support out of the box to do these checks or to express these constraints. And also it's challenging to cancel more tests. So if you have hundreds of tests and they depend on the same condition, I'm not sure if there is a way to factor out that and do it in a more succinct way. Okay, so let's see how we can write modular fixtures, because most probably we will have a lot of modules and we want to share them, at least the code between the tests, so that we don't repeat the same setup and tear down logic in every test file. So the one way to do this is to extend async test suite mixin. Here, this example shows you how to start a Postgres container and how to stop it at the end. There is this complete lastly structure that is very similar to try finally. It's just for the asynchronous case. Another example is when you need to depend on the module or the component that we set up earlier. So this the queue context that we want to set up depends on the Postgres container. So this is the way how you can do that. You just extend that trait and use it to set up your context. So eventually you will have a lot of modules and dependencies, and you can mix all these into your test and use it to implement that test suite. The problem is that so the lifecycle of these modules are hard-coded in your mixin. So either you chose to have like your progress container start up for each and every test, or you chose to start up for the whole suite and have it shared among all tests, but you cannot use at the use side the lifecycle of this dependency. Another problem is that the fixture setup is sequential, so you need to wait to finish, like setting up the container. You cannot do something useful concurrently. And if you want to share all these dependencies between all the test specs that you have, then you might need to resort to hacks like having a global shared mutable variable where you can set up the dependency and tear it down at the end. Yeah, so just to recap what were the problems. We cannot interrupt the tests. The retry schedule was hard-coded. There's no out-of-the-box support for writing environment-specific tests. The lifecycle is hard-coded of the dependencies. Fixture setup is sequential, and sharing fixtures among all the tests requires some global state. So my point is not to bash on Scala Test because it's an excellent framework for unit tests, but these are real problems, and how Scala Test tries to solve these problems is very much the object-oriented way. And I'm also sure that if you try hard enough to solve these problems, you will find a way. It's just, it's not something that you get out of the box. So in the next section, let's see how we can try to improve on this experience with functional programming on ZIO Test. So this is how you add a timeout to your ZIO Test. It's just easy. You just use the timeout aspect. If you have a flaky test, again, there is an aspect for that. You just say flaky, retry 10 times. You also have the option to not use flaky, but use retry, and then you can specify a schedule that is as sophisticated as you need. If you have an environment-specific test, then you have great support. You have like aspects that constrain your tests to run on specific platforms or operating systems. You can also check environment variables and so on. So yeah, so let's look at what we ended up. Does this remind you to something? It looks like Spring Boot or something like that, where you have more annotations than the actual code. So, but if you fear that aspects are similar to annotations, then don't fear that, because these aspects are first-class ordinary values. They're basically functions from spec to spec. Also, this add method is an ordinary function on spec. So there is no need to annotation processing if you want to come up with your own spec. You can easily extend what we have. Yes, and aspects, since they are first-class values, they also compose. So you can factor out if you have repeating aspects, you can factor out the commonalities, and this is how you do it. You just use another operator, use this arrow operator to do it. Okay, let's talk about resource management or dependency management. So if you work with ZIO, then chances are that your components are already bundled up as layers. And you can do the same thing with test-specific dependencies. Here's an example first I wanted to talk a little bit more about this. So here we just set up the same Postgres container. We just have to define an acquire and the release action. And in the second example, we depend on this container and set up the QL context. So this is how you do it in ZIO Test. This is just a quick recipe what you can do if you have like test data to load. You don't have to have the whole boilerplate to define a service, trait, and so on. It's just you write a case class. You have an effect to populate that case class. And you can just wrap that up in a layer by calling toLayer. Yeah, and at the use side, you just grab that the dependency from the environment and call the accessor method to take out your test data. So once you have all these dependencies, then you can write a more realistic integration test where we use all these dependencies, and all we have to do at the end is to provide all the layers. And what's cool about this is that layers are being initialized asynchronously without blocking, so you don't have to wait with loading your test data until your Postgres container starts up. They don't have to do anything with each other, so why not do them in parallel? So if you have multiple tests, do you have to provide each and every test? Of course not. So you can just move the provide invocation to the suit level. And actually, ZIO Test allows you to nest your tests in arbitrary levels. And you can flexibly provide the dependencies for each and every sub-suit. And at the end, you can provide the common dependencies for, that are used in all the tests and suits. So what we do here is actually, even though the provide is at the suit level, what we achieve with this is that each and every individual test will use their own fresh instance of their dependencies, which might be what we want, because then it's very convenient to write tests. There is no interdependency between the tests. each and every of them will start with a clean sheet. But some of these layers might be very expensive to create and destroy. So yeah, just imagine that you have a database. You have to open a connection to the database, initialize the database driver, create a connection pool, and tear all this down at the end. So this costs a lot of time, and 100% that you don't want to do this for each and every test. So what you can do in this case is just snap this shared prefix after the variations of the provide method that you use. And this is very important because this is the key if you want to make your tests run faster. The key is to share these heavyweight, expensive dependencies. Of course, the downside is that you need to be much more careful with your test because now there is interdependencies, so watch out. Yeah, so just to visualize this a little bit, because it's an important point. So if you use provide, you only use that if you want to take a nap while you are running the integration test. If you want to be the cool guy with these sunglasses, then you use provide shared. And that's very fine. You will be the hero in the team until someone comes along and copies your test. And you end up with 2 tests, and the dependencies are not shared anymore because provide shared can only share the dependencies within the same spec. And chances are that this will just go on. People copy and paste. And wow. And this is not necessarily the result of sloppy developers in your team. In massive, large code bases, where you have dozens of different modules, oftentimes you just cannot share everything that you need or everything that all these tests depend on. So this lack of resource sharing across specs made ZIO Test not able to scale with large projects. And in some instances, it actually prevented adoption. So let's see how we can tackle this problem. So in this slide, I show the version of your tests in ZIO 1 and ZIO 2. And this might be this silly game to try to find the 2-3 differences between the picture on the left and right. But I highlighted the plus sign on the right. So what we have here is a new way to write your specs. Because in ZIO 2, suits and tests compose. So you can add them up to create larger specs. So we already know that environmental dependencies compose as well. So if you have two effects and they depend on, one is depending on A, one is depending on B, when you compose these effects with flatmap or something, then you have an effect that depends on A and B. So they compose as well. So functional programming is all about composition. Why don't we try to make the specs themselves compose? And this is actually what happens in ZIO 2. We have new base classes for tests. The simpler one is ZIO spec default. Here's an example how to use them. It's the same way. It's just you just extend another class, and it makes it possible. At the bottom line, you can see this angular bracket operator to compose them. But that's not very interesting, right? It's just a default test without any dependencies, or all the dependencies are actually provided within the test. So it's not very exciting. It gets more interesting if you use ZIO spec and you supply in the type parameter the dependency that you want this test to be provided. Of course, you also need to specify how to satisfy this dependency, because the testing framework will not be able to supply a Postgres container and the context, query context for you. So you need to define this abstract method called layer. But notice that you don't have to provide this dependency to your tests. You can still provide some specific dependencies that particular tests depend on. So here I have alert service and customer service for the two specs that I have. But I don't provide the Postgres container and the context. So what this new feature allows us is, as I mentioned, also with the default spec, that at the end we are able to compose the two specs, although they are in different files. But this is not something that you will do manually. So all this happens automatically for you when you use the SBT test runner. And what the SBT test runner actually does, it collects all the specs according to your command line. So if you just restrict to run a few tests, it doesn't matter. Or if you run the whole test suite, the SBT test runner will collect all the specs and compose them all together into one single spec, and will execute that one. And yeah, so this is the effect that you have. Now we can be the happy little nerd guy at the bottom, because all our specs and tests use the same infrastructure, regardless how many files they are split into. Yeah, one last thing here is how you can opt out from this behavior if you need. You can just use the fresh method on the layer, which is nothing new. This has been already there. So just use that if you need to opt out. So as a summary, we have seen that integration is challenging. And ZIO Test provides already a nice solution, but with a major pain point that we couldn't share the specs share the dependencies among specs. And ZIO 2 now solves this problem using composable specs. And I don't have much resources to share right now. I think as we approach the release of ZIO 2, we will provide more code examples. I will upload my slides later and share the link. And yeah, basically that's it. Thank you. I would like to thank the Ziverge team for providing me the opportunity to work with them. I would like to personally thank Bill Fraser, because he contributed this feature into ZIO 2. I also worked on this feature on the basis of ZIO 1. But in ZIO 1, we can only have a very hacky way to achieve this. And with the composable specs, it's much more elegant, and Bill has contributed this. And I would like to also thank John for his mentorship. Thank you.
Thanks for the fantastic talk. That was great. Between that and the prior talk, I think we got both the introductory and the intermediate to advanced versions for ZIO Test. So that's really a fantastic talk and fantastic knowledge there. And I know a lot of people have been interested in that. So thank you so much for sharing there.
Thank you very much.
I think we do have some time for questions. So I think we got one in the back there.
Thank you for the talk. Have you put any thought or experiments into getting support for automatic spec composition under Bazel and not just under SBT?
Yes, this is specific to SBT. So it's basically the mechanism that composes your specs is within the SBT test runner.
Have you considered trying to do something similar under Bazel?
I'm not familiar with Bazel, but I'm sure that it's possible to implement the same thing in Bazel. There's nothing magical about it. It's just using this angular bracket operator to compose all the specs together.
Yeah, just to add to that, I think it's an area where pull requests would be welcomed. I think the fundamental functionality is there. As you said, it's just the composition of these specs, and so it's really just a matter of detecting them and then combining them, which there's some logic in the SBT test runner that does that for SBT, but I'm sure that could be implemented for other frameworks, and we certainly want to support everyone who wants to test however they want to test. Any other questions in the room? Okay, well, we got lots of people on the Discord who are very excited about this and lots of claps, so thank you so much.
Thank you.